Hello everyone. Welcome to JCoV webinars. We are glad that you're with us. We are back online. Hello everyone. My name is Roman Mearson. Call me Roma, please. I'm a driver of JCoV initiative. I'm glad to be here with you and host our new webinar for you. So today we have really interesting topic, and I hope it will be interesting for you, of course, as all our topics. Before I will invite our today's speaker to the room, please let me remind you that first of all, this is YouTube channel where you are right now. You may be on VR community platform. There is like video from YouTube is integrated there. So please subscribe to our YouTube channel, subscribe to our community on VR community. All the links may be found in the description to this video. Yeah, please click bell button and click like button. We really appreciate that. We know that this is valuable for you. We will know that you like our webinars, so please do that. Also, as ask from my side is that you just go right now to your colleagues and share with them that there is this great webinar which you are attending at, and we'll have more people who are watching us, who are here with us. So it would be really also cool. And also after this webinar, you will receive a feedback form. So we're really glad to read all your feedbacks, good or bad, like any feedback. So it's appreciated. We try to make us better, try to make our webinars better. So please do that. Yeah, that's an ask from my side. So yeah, I see your hellos in the chat. So as a reminder, yeah, yet another reminder. We have two chats basically. One is on VR community platform near the video. Second one is here on YouTube. So both of them are being monitored by me. I will check all your questions and all your highs, everything there. So yeah, you may use both of them to send us your messages. Also, please use it for discuss what is happening on the webinar with people who are also watching it. Yeah, I will look at the questions in both of them and ask them to our today's speaker. So I'm stop talking. I stop talking. Maybe I should record this and start from recording each webinar. So let me invite our today's speaker. It's Ivan Zvieriev. Ivan, hello.
Hi, Roman. You can also call me Vanya, as we call you Roma.
Yeah.
We have two Ivans now in the team, which is very seldom situation, and we decided that we call me Vanya.
So okay, no problem. There was a feedback in one of our webinars that like, Roma, stop calling people with these like shorter names. Like if a person is called Alexander, call him Alexander, not like Sasha or Alex. In this case, guys, I have an ask for a speaker to call him Vanya. So yes, exactly. That's what I would do. Okay, Vanya, can you tell us please a bit more about your talk and what would it be about?
Should we start sharing the presentation? Because
not yet. Just a small talk.
Just a small talk. Then today we are going to speak about JVM. Yeah, the talk is called like send and say techniques for reducing native memory footprint. I would like not to focus on that, like we should reduce memory, etc. We are exploring JVM. Yeah, its parts, from what it consists, etc. So memory is just like our guide to have some direction, to have a vector. Yeah, but the main goal is to explore the JVM.
Okay, great. So guys, today we will have a lot of deep stuff, something that you may be not touching for everyday work, but it's good to know, good to know about that, and good to have it in your mind. Okay, so I think we don't need to waste more time. So let me put your screen, Vanya, to the broadcast, and it's here. Good luck, guys. Just a reminder, your questions in the chat, I monitor them. So Vanya, good luck. Let's go.
Thank you.
Oh.
I'm Vanya. Now it appears that it will be Vanya. And welcome to Sane and Insane Techniques for Reducing Native Memory Footprint. Before we start, I will, for those who already know me, my condolences. For those who don't, I'm software engineer for more than 10 years. In EPAM, I'm 6.5 years. worked in very different roles. I was developer, team leader, product owner, scrum master. Easier to say whom I was not in EPAM. 10 years in IT in general. I have 2 kids, 2 huskies, 1 wife, now a turtle. I'm streamer, Hearthstone legend, trainer. I'm doing some trainings on technical topics and soft skill
I'm sorry.
topics. Yeah.
I'm really sorry to interrupt you. We have an ask from the audience to, if possible, to bring your microphone a bit closer, or maybe I can make it a bit louder. Let me try that.
Of course. I can take mic closer, or you can make me louder. How you prefer.
Okay, try to say something now.
I'm saying all the time, you know.
Okay, I think it's better. I'm really sorry for interruption. So guys, yeah, if it's better, please type us in the chat. So I'm out.
Good. So you can find me on Twitch. I'm having the channel now dedicated to 2 topics, Hearthstone and Java. So on Thursday, 21 Central European time, every Thursday we are having some interesting stuff about Java, particularly about low latency, everything what is related to it. Okay, that's about me. Now about our today's agenda. First, we will speak a little bit about some water. Every presentation should have some water. We will have mine in the beginning and then no water anymore. Then we will come to same part, how we can lose the weight of our memory, of native memory, of our application, somehow tuning our threads, tuning our compilation. I will show you something on class data sharing, and in the end about garbage collection. Then we will go to insane parts. Yeah, we will speak about threads. We will be shrinking code cache, and we will shrink class metadata storage. In the end, cautionary tale about bullets. That's about agenda. And before I proceed, I would like to say words of appreciation to this guy. This is Alexei Shepilov. Currently he's working for AWS, for Amazon, previously Red Hat, previously Oracle. Yeah, so I was inspired by his article. Actually, it is called the article is called Native Memory Tracking, and based on this article, I've built all the talk. So it's not fully my author content, despite of course I've brought my own parts, but basically this is the guy who inspired me. And he is, by the way, the author of JC Stress. Also, he's one of the authors of Shenandoah Garbage Collector, and a lot of stuff which is in JVM, he actually written. And water. Now, water. What do we know about water? Everyone uses water on a daily basis. We know some stuff like that it can be solid, it can be liquid, it can be gas. We know how to use it. We can wash clothes, drink, bath, take shower, clean something with water, right? Why I'm saying all that? We do the same for JVM. We use it on a daily basis. Every Java developer, every Java application is running on JVM. Question now, how much do we know about JVM? Because, for example, if we go deeper about water, yeah, I guess everyone knows about that. The water is like two atoms of hydrogen, 1 atom of oxygen. What does it give you in real life? What does it give you in practice? I guess not very much. In practice, you use your JVM as JVM, yeah, and you use water as water. What it gives you, it makes you more educated, I would say. And the things which I will be showing you, they are, you will not go to your project right now and start applying them in practice. Most probably not. And in the end, I will even not recommend to do it. But knowing about them and being aware of all those things which are happening inside JVM will make you much more educated, and you will do a lot of things, maybe more conscious when working with JVM. Okay, that's basically the slide. Now let's set the stage. Yeah, let's see what do we need to track native memory. As always, some people are always complain, but about using HelloWorld as an example. But what can be more simple than HelloWorld? Yeah, so we run it. It's HelloWorld. Super. So now, question: how much memory did we consume with running this application? And I'm intentionally saying that running your application, because I intentionally make this, let's say, I would call it an error, yeah, because we are not running our application. We are running JVM and give our main class as a parameter to JVM. So JVM takes our main class as main and start doing something with it. So we don't run our application, in fact, right? We run JVM. And now question, how much memory did we consume with this application? Me, to be honest, I don't know for sure. And let's find out. So we have 3 options which we need to add to our run configurations in order to see it. So we add VM options. Here they are. Sorry, one. Okay. First of all, before doing adding any more options to JVM, we need to unlock the agnostic VM options, which are disabled by default. Then we enable native memory tracking. Why it's not copying normally with Control-C? Here we go. So we have now memory tracking, and we will not use detail. I just sent it, left it on the slide so we have that. It can be very, very much detailed. We don't need this level of details. We need just summary. And the last thing, print NMT statistics on the exit of JVM. So this one, when JVM stops, it just prints out on the screen whatever we have. Yeah, that's our parameters. Let's go. And I guess I put them in the wrong window. Again, wrong window. VM options here. Run. Come on. On dry run, it was all working properly. Native. I pasted wrong option. Something is wrong with my copy pasting today. Sorry, guys, for that. Yes, now it should be okay. Yes. So let's have a look. And what we see that we have committed like native memory. You see that there is a total. We reserved some memory from operating system, and we committed some memory to operating system. And this is the number which we are actually interested. So in fact, our HelloWorld application has taken almost 1 gig of memory from operating system. Is it okay or not? I'm very hard to judge, but to me, it's not okay. Yeah, so we have taken, like, to be precise, now let's go to my slides because I've converted everything to megabytes, 892 megabytes for HelloWorld. So let's restrain it. Yeah, we all know that Heap is taking the biggest amount of memory of JVM. Let's set 2 another flags. Minimum minimum heap size and maximum heap size. So we say JVM that we need to take exactly 16 megabytes. Yeah, so minimum, maximum size 16 megs. Let's try it. And what we see, yeah, it's much better now, but still committed this amount of kilobytes. So for HelloWorld, JVM has taken 125.63 megabytes. By the way, if you are using different version of Java, if you are using different hardware, this number can slightly differ. Yeah, so don't take it as like that every JVM will take 125 megabytes. Maybe if you will take some OpenJDK, for example, it will take less or more, I don't know. But still, 125 megabytes for HelloWorld. For me, it looks like a little bit too much. And let's go and try to reduce it. The first thing we would like to do, we will be working with threads. Question, is our application multi-threaded? Our application is not, but definitely our JVM is. And let's have a look at this section. Yeah, you see it's thread. It's committed 50 megabytes to somewhere, to whatever, to creation of threads, etc. And we see the number of threads. Our HelloWorld was using 40 threads. Let's see how we can tune it to make the memory footprint a little bit better. We will now reduce the stack size to 256 kilobytes. So the default stack size which our threads are allocating is 1 megabyte for JVM version 8. That's why we add another parameter, XSS 256 kilobytes, to our list of parameters which we already have.
Vanya, I'm sorry to interrupt you again. Can we do two things just to check? So if it's possible to increase the font size for the terminal where their application is run, if it's possible to do it anyhow.
Yeah, let's try. Let's try, but I honestly doubt that.
It's editor, yeah, and remove everything from search on the top.
Okay.
And then editor, general or font. I don't remember. Let me just check it briefly. Editor font, and there is size of the font. A bit upper. Oh, yeah, font, and there is size of the font. Please change it to something a bit bigger, like, I don't know, 20 maybe.
Yeah.
Yeah, I hope it's better. And second thing, can you please in StreamYard check the microphone which you're using, if it's correct one? We had an ask from the guys to check if it's a microphone from your laptop or it's your external one.
This is my external one.
Okay, great. Then yeah. So again, sorry for the interruption. Just ask.
I can try to increase the sound a little bit.
No, I already increased it. It's became better, but there was just an ask that maybe wrong microphone. So yeah, guys, I hope it's better. I hope now we can see better the font. So yeah, let's proceed again. Sorry for interruption.
No problem. Everything for our watchers. So 40 threads. What we are doing, we are reducing the stack size of the thread, of each single thread. So currently we see that it's 40 something kilobytes. Now we have added this new parameter of 256 kilobytes, and now you see we already reduced our footprint for 5 megabytes, which is not bad. Let's go to a very HelloWorld topic, because currently we are on the stack of two different topics, of threads and of compilation. And question is Java compiled language or interpreted one? And here I divide, let's say, people who know something about Java into like very beginners who will say that Java is compiled by Java C and it will be executed. This is not till the end correct, yeah, because Java C is not compiling. Because compilation is something that we translate the code into machine instructions, yeah, and bytecode, which is produced by Java C, is not machine instructions. It's bytecode, which is interpreted by JVM. The next, and I was on this level, on the second level, I was for a very, very long time. I would say that, yeah, our code is not running 10,000 times. That's why it will not be compiled. Yeah, it will be used as interpreted code, and here it is. Our HelloWorld will not compile anything because it runs less than 10,000 times. Now, the correct answer, yeah. On my current level of my understanding of JVM, I would say that it's combination of both, yeah. So at the beginning, we start interpreting the code, and then at some point, we compile it. How do we do that? Yeah, and here is the slide which is showing that. Basically, we have 5 levels of compilation. The first one is interpreter 01. It's like totally not compiled. Then we have 3 levels of C1. So we have 2 compilers in JVM. One is called C1, another is called C2. Initially, if you remember the times when JVM was able to run into 2 modes, server mode and client mode, yeah, the client mode compiler was C1. And the server mode compiler was C2. Now this kind of very, very deprecated, I guess no one is running JVM now in client mode, but there are still 2 compilers, which are very heavily interacting between each other. So when you start like your code, it executes like 1 time, 2 times, it's still interpreted. After 1,500 times, C1 with no profiling, compile it to already machine instructions. And then the profiling starts. Yes, so it starts like doing profiling, and it can recompile. It can recompile with full profiling already at the level 3. And at level 4, C2 compiler is jumping in. Yeah, so the difference between them is that they have different type of optimizations which they can do, and C2 has already all like profiling information which he needs to perform the best possible optimizations which it can do in order to make your code much faster. So now again the question: in our Hello World, which is running only 1 time, will something be compiled? Instead of like speculating about that, let's see. There is another JVM flag. We will have a look at a lot of them today, which is called print compilation. So it will show us all information about the compilation which our JVM performs. So let's do that with print compilations. And yeah, look at that. It appears that there are a lot of compilations happening even for our Hello World application. Why is that? Because JVM, for starting, yeah, it starts to do a lot of different stuff with the methods. And for example, I will not go too much into details. Just here it's some idea of compilation. And here is the tier of the compilation. Yes, so these tiers which I was showing you right now, char add method, for example, is already compiled to tier 4 in HelloWorld. Yeah, so there are a lot of things which are happening, and here we have 4, and here we have 4. Yeah, so tiered compilation is happening in the background, and of course, I don't recommend to disable it, but this is what we are going to do right now. We are going to reduce the number of threads in general, which JVM is creating, by disabling this tiered compilation and setting the number of compiler threads to 1. So I'm copy-pasting these 2 flags. I will switch off this print compilation flag because we don't need it anymore. It was just in demo purposes. And here we are disabling now tiered compilation and setting this thread amount of compilers to 1. With doing that, we will have only 1 compiler left. We will have only C2. So C1 will not play in part. So we don't disable compilation completely. We disable tiered compilation, all the mechanism which stands behind tiered compilation. And let's see what we have now. Thread. You see the number of threads dropped from 40 to 29, and we immediately gain a memory footprint. So on slides, I guess I've put a comparison. Yeah, so from 40 threads and 33 mega to 29 threads and 22 mega. So 11 more megabytes we have saved with disabling tiered compilation. And now we are coming to the, I would say, the main abuser of our HelloWorld application. It's garbage collection. A lot of people, I want to give a small recap because discussing with people on interviews to EPAM, the people who are trying to join EPAM, I usually ask, what do you know in general about garbage collection? And what garbage collector do you use? Usually they say just we use default one, and I'm asking what's default one for you? Yeah, so if it is Java 8, what is default garbage collector? It appears that a lot of people still think that G1 is the latest possible option, and currently everyone is using that. Yet we have newcomers recently. I would say that ZGC, Zero Garbage Collector, was introduced yet in Java 11, but as experimental feature. And in Java 15, it's already full production-ready garbage collector. And I intentionally, I put it not on the slide, but I left it open for on the Oracle wiki to show you that currently, starting from JDK 15, it is production ready, and it's concurrent, region-based, compacting, etc. Yeah, so here is the small like why it was not introduced, like, and a lot of people didn't use it long ago, because since JDK 15 and in many cases 16, 17, 18. It was not available for all the platforms. So starting from JDK 18, we have it almost everywhere. Yeah, so all platforms now ZGC is available and we can use it. Yeah, and it's one of the like greatest additions to JVM, I would say, to Java, which is working with low latency, because the main goal of using ZGC is to make the stop the world pauses very, very small. So it says that it's 0. It's not in the fact true. It still have stop the world pauses, but they are sub-milliseconds. So the biggest stop the world pause will take like less than 1 millisecond. Shenandoah is not yet production ready, to my knowledge, and that's why you most probably don't see it in production yet, but it's also low latency, low pauses collector. Yet it have very interesting modes. So you can, in default mode, Shenandoah is behaving. It's just, I didn't put it on slide because I watched this talk about Shenandoah just 2 days ago, and I was not able to accommodate it, but I want to share that, yeah. In standard mode, Shenandoah is usually very memory consuming. So it allows application to create as much garbage as possible, yeah, to consume the heap as much as possible. And when the application starts to be less busy, to go to some idle mode, yeah, it cleans this memory and reclaims it back. Yeah, so it gives the memory back, yeah, to the system. But there is another mode which is called, I guess, compact for Shenandoah. It is optimized exactly to consume as few memory as possible. So it's like special mode for keeping your memory footprint of your Java application as small as possible. So you can run it in those two modes, but unfortunately yet not in production. Now let's have a look at what we have for our application. Garbage collector is taking 22 megabytes for HelloWorld application and for 16 megabytes heap. So if we will increase heap, and if we will make our application a little bit more complex, I would say that it will consume more. And I'm using Java 8. That's why default garbage collector is serial. So we are now tried it with a serial garbage collector. It's also like a big, very, very often mistake. People say that G1 became default starting from Java 8. It's not true. It was added to as production ready in Java 8, but default was still serial parallel garbage collector. Yeah. So it became default garbage collector for all Java applications starting from Java 9. So using Java 8, we have default garbage collector as serial, and now we will try to use G1. Let's see what will happen with our memory. So let's have a look. 22 megabytes on parallel. 70 with G1. Yeah, so G1 is, let's say, more modern. It's like very, very nice collector, I would say, but it has its cost. Yeah, so the overhead of G1 GC, you see, it's like 3 times bigger than we have for parallel. And now let's go to, let's say, less popular collector, which is usually on interviews. People say that it's not used, but sometimes it's used, for example, on the stock. So let's try it with serial garbage collector. 100 kilobytes. So currently our overhead on garbage collector is 100 kilobytes instead of 70 megabytes. So we just saved, from parallel, we saved like 20 megabytes, but from G1, we saved 70 megabytes of memory with serial GC. Someone could argue, yeah, that serial garbage collector is serial. Yeah, it gives a huge pauses, but in the world of low latency, garbage is considered one of the biggest problems of low latency applications, just because of that, because of garbage collection and its pauses. That's why people do like even different techniques to how to write the code not to produce garbage. Yeah, so I have seen in my practice, like the application was started, then there is explicit call to garbage collector, so that during startup they clean up after startup all the memory, they warm up the application, and then the garbage collection is not triggered any single time, because they have pre-created like arrays, they pre-created collections, all the stuff, and they are of limited size, so the garbage will not be created. In this case, why not to use serial garbage collector if you know that we are not producing any garbage? So we are not planning to run any garbage collector anytime in our application lifecycle. Then there is an option. Yeah. Still, of course, you will be very, very strongly penalized if the garbage collector will have garbage collection will happen. Yeah. Then you will understand all the negative effects of using serial garbage collector. So we reduced it on 20 megabytes, and in total we came now from 125 megabytes to 30. Yeah, with those operations. Despite, let's recap what we did. Yeah, we reduced the stack size of the threads to 256 kilobytes. Is it reasonable? Depending on your application. If you know that you are creating a lot of threads, but they are small, they are doing small amount of work and then they die, then maybe there is a sense to give a small stack size. Yeah. The other part of it is, of course, you will risk to fall into Stack Overflow exception very easily. We removed tiered compilation and reduced the number of compilers in your application, which is very not for 95% of applications. It's very bad practice to do that. Yeah, and I don't recommend to do that. But if you know that, for example, your code is very, very it's similar stuff which is happening again and again and again, and you kind of understand what optimizations can be done, and you don't need this. You have possibility to warm up your application before it goes into full power. Then there is another option. Now I will show you some mystery. For me, I have never, before reading this article, I have never heard about it. Class data sharing. What is that? It is some mechanism of JVM when standard classes of which are included in every JVM on your machine. They create a lot of standard classes, of course, for you. And it appears that it creates a common space somewhere on maybe on hard drive. I'm not sure. I didn't went too much into details how it works, but they can actually not create but reuse this metadata, class metadata sharing mechanism in their application. And Alexei, while doing his experiment on JVM, he was using this option xshare on. And he received some save in the memory, so the memory reduced. Let's have a look what we have right now. Yeah, right now we have committed 30 megabytes approximately. Yeah, 31. Now let's add this option here. And run it once again. And we have lost somewhere 18 megabytes. So in my experiment, it appears that this class data sharing, instead of saving us some memory, it adds additional overhead of 18 megabytes on the memory. I decided not to remove it from presentation because I thought, okay, yeah, here we are not reducing memory footprint. I need to remove it from presentation, but then I decided to show it. Just here is the link. I guess slides will be shared with you later, but there is a link to description, what it is, how it works. if you will be interested, you can go in more details. I will stop here for the moment and say that in our experiment, it didn't work out. Yeah, so it didn't save any memory. Now we are going to switch to insane parts. I also, like a small disclaimer, I wouldn't say that the things which we have done right now are very sane. That you need to go to your project and start immediately disable tiered compilation and switch the garbage collector to serial. Yeah, but those were still like the things which you could predict the consequences, and you can measure the risks and benefits which you will receive from that. But now we are going to the parts which I suppose there is no predictable outcome of what we are going to do. So let's go deeper and see how much more we will be able to save. First of all, we have already reduced stack size of our threads, which our JVM is creating like Java thread, like JVM thread. No. Our threads, yeah. But now we will say that all threads which JVM is creating, even for its own purposes, yeah, we are reducing its size also to 256 megabytes. Yeah, so VM thread stack size. So whatever virtual machine is creating a thread for its own needs, etc., it will now also have only 256 kilobytes of stack. Let's do that. I will disable Xshare on. And just for the visibility, I will run it once again without this option. So we have 31262. Now let's add here this option. 256 kilobytes for JVM threads. You see, we saved 3 more megabytes. Question, can we predict the outcomes of this action? I cannot. So I have no idea for what purposes which threads are created and how much of stack do they need. So we can go even like smaller. We can try to give it 128, and it can still work for HelloWorld. But for more complex applications, it can be really bad option. The next insane thing which we are going to do is we are going to reduce initial code cache size. What is that? Yeah, so the C1, C2 compiler, while compiling the code, yeah, it put it somewhere, and there is a special space which is called like code cache. And now we are going to reduce it to 4 kilobytes. So we give compiled code possibility to be stored only in 4 kilobytes. Let's see. I guess it's in the code size should be, but we will look at overall. Now we have 28. Yeah, of course, I didn't have the option. Of course, getting it now. So already 3 times. That's too much. Initial code cache size. Boom, boom. So we have 29. Now we have 26. So 3 megabytes more. Yeah, we saved, and you see here it's like it's reduced in this section. So it's now 550 kilobytes. question. What will happen if we will fall into some big compilation, or if those compilations will be like, they will be frequent? I'm not sure what will happen. I don't think that we will run into some kind of exception, but there can be a strong like not optimization, but performance penalty. Like, that's why it's insane. Yeah, we shouldn't shrink our initial code cache size to 4 kilobytes. But there is one more thing which we can go even more. We can reduce the boot class loader meta space to 4 kilobytes. So every time when the new class is created, it's creating like some space for its metadata. It's stored somewhere, and it takes some memory. So let's reduce it to 4 kilobytes and see. So now we have 26. Now we have 25. So 1 megabyte more we were able to save. And I would say that we can go even deeper. So we can reduce it even more, but we will not. Yeah, so not in scope of this talk, not today. And let's have a look at the final result. So we reduced it from 125 megabytes to 25 megabytes. So we have saved like almost 100 megabytes of native memory. And let's revise what we have discussed. Yeah, so garbage collector, we need to use the proper one. Yeah, if you are not planning to produce garbage at all, like for some low latency applications, it's reality, then serial one is a very good option. Threads, your threads, JVM threads, maybe we went a little bit extreme, reducing it to 100 to 256 kilobytes, but maybe 512, it's already something. So we can save something on compiler, and on this code cache class metaspace, small improvements, which definitely I don't recommend to do. And now, before we came to a bullet story, I would like to show you one small, because I've cheated a little bit. I must admit that. The initial experiment was done on Java 8, and that's why I repeated it on Java 8. But if we will take Java 20, we will definitely receive different results. And I didn't yet found a good explanation for that, so you can share it on in the chat if you like, not in the chat, but there is a community page where you can like post the comments, and if you will be interested, you can make your own investigation of that. But I now remove all the options which we used and try to run the same story, but on Java 20. And here we will have a small difficulty because output is in bytes. Yeah, so it's giving bytes. And that's why I've prepared already the converter to megabytes, so that so this is without heap limitation. Now our hello world on default Java 20, without modifying any options, without setting anything, will take not 850, but it will take 620 megabytes, which is already like a good saving, I would say. Now let's do the same operations as we did for our whole exercise. So first of all, what we were doing, we were reducing the heap size to 16 mega. And we will do the same for Java 20. Run it once again. And let's see. For 16 megabytes, we have 110 megabytes of memory allocated. So it is already better than we had here. Yeah, here we had 122 megabytes for 16 megabytes heap. So since Java 8 to Java 20, yeah, some work was done and the memory footprint reduced. And now let's try to do this thread operation. Let's have a look at threads here. We have already like 40 threads again. We have committed 90, 93. Let's convert it to be precise. Look. And on stack. It's a very, very small part. And we will not be able to go very much because how like falling less than to less than 1 megabyte, it's almost impossible. I didn't find the explanation for that. I would be very honest with you. I didn't find, but I have a guess, and I will need to check that. Project Loom, which is having like virtual threads, went out experimental in Java 19. So I assume that in Java 20, under the hood, they already use virtual threads from Project Loom. I cannot be confident about that. I'm not promising that, but maybe my next talk on this platform will be about Project Loom. Yeah, because for me now it sounds like you remember the time when Java 8 went out, and for the next 5 years, one of the most popular interview questions was, "Have you worked with Java 8 and with Java 8 features?" The same will be after Java 21, when Project Loom and virtual threads will go live, production ready. It will be the next like milestone, I would say. It would be so greatly amazing, because I watched several talks about this Project Loom already, and looks like you can create millions of these virtual threads in your JVM, and they almost don't consume. So currently, like, what is the difference between those virtual threads and real threads? Yeah, and threads which we have now in JVM. Currently, one JVM thread means one thread of operation system. With virtual threads, it will not be like that. So you will still have the amount of threads which you created as threads in JVM, but virtual threads will be inside them. So the operating system will not create a thread for each virtual thread you will be creating. So it's so amazing, and yeah, that's to finalize.
Drop in here for a second. So guys, if you want to check more about Project Loom and virtual threads, we have on our channel talk from Alexander Filichkin about that, so feel free to check that. I'm not sure that, like you guessed, that Java is already using virtual threads under the hood is correct, because we still need to use a flag to enable virtual threads, so it will be enabled all across JVM. But I think that for Project Loom, they did some enhancement, like not some, a lot of enhancement in the internals of JVM. So yeah, that's maybe connected. But it's not about virtual threads themselves, but just about like refactoring and refinement of all the stuff which is there.
As I told, this was just a guess, not checked before the talk. And actually, we can not Roma. You can stay live, because I have nothing more to show. I have one story just to tell in the end. This is a real story, that's true. 1 year ago, I wanted to to try to shoot, yeah, and to go to a shooting range. And here in Danzig, I have a colleague who is very much into shooting. He's he has a license for a lot of guns, etc. And he took me on the shooting range, and we started shooting. And after we completed, yeah, he started to collect the shells from the bullets. And I was like, why you are doing that? Why do you need them? And he says, I'm doing my own bullets. I say, why? Is it cheaper? And he's not very much cheaper, but I put a little bit less gunpowder there, and I'm participating in the speed shooting competitions, and this less gunpowder gives me possibility the like when you shoot, the gun is giving you like throwback. Yeah, so this throwback becomes a little bit softer, and that's why my pointing stays the same. It's more steady. And I was like, wow, that's amazing. And this is why I'm telling this story right now is think about how many people do their own bullets and why they are doing them. Yeah, so 95% of the 99% of the shooters, of the people who ever use the gun, use just standard setup, right? So they take the bullets, the ready produced bullets, and they don't. I will not risk myself to do my own bullet. I'm not professional in that, and this will be dangerous. I will not shoot my own bullets, even if I will produce them. The same with JVM options, and with JVM flags, and with the techniques we have shown. So you need to be very clear why you are doing that. You need to be very clear about what you are doing and what could be the consequences. Yeah, what could be the benefits and what would be the risks and consequences you take while applying these techniques. Pretty much that's it from my side. Thank you very much, Roma, for inviting me. Now, I guess if we have any questions in the chat, we can try to answer them.
We do. So first of all, I would emulate the audience, when you are in the hall and make presentation. I would do it. Thank you very much.
I have special sound for that.
Wow, great. Yeah, I should also do something like this for preparation. So yeah, we have some questions, of course. First of all, thank you very much for your talk. Really useful, I think. First of all, we have some discussions in the chat regarding what is compiler, what is to call compiler, and how maybe you should rearrange your talk. So guys, please put all this stuff in the feedback. We will read it, and this is what we would use for our future preparations. So Vanya, from my side, thank you very much for your talk. Very useful, very hands-on. And now let's move to questions. So first one
I promised in the 1 second. I told that I'm going to start HelloWorld right now. You remember?
Yeah.
It was on my presentation, so I started it. That's good.
Yeah, sure. Okay, so first question was from Vasily. When you showed very first checks on thread, there was a number 40 threads. The question is why it's exactly 40. Of course, we reduced it later. So question was how can we trim it down? Okay, it was shown, but why the amount of threads is exactly 40? Do you know that?
I cannot answer exactly why 40, and I would say that on different JVM you will get different results. I was doing a special talk about what those background threads of JVM are doing. So basically we have at least for garbage collector, we have a special thread, for example, which is doing only finalizing. You know this finalizer keyword, yeah, finalize, which is never recommended to be done. Yeah, so there is a special thread which is taken care of when the object was marked as eligible for garbage collection. It is going to special queue, which is called to finalize, or I don't remember the name of the queue, but this thread is taking those things and executes finalize method in these objects. Yeah, so this is one, for example. There are special threads which are hanging to wait for RMI connections. So each JVM should be ready to accept RMI connections, and there are I guess 4 threads of them, something like that. Others, to be honest, I don't remember exactly, but there is a number of threads which will always happen in your JVM when you start it. Yeah, and starting from version to version, even hotspot JVM, yeah, Oracle 1, from version to version, it will be different amount, yeah, because sometimes they change something internally. Now they need additional thread running and one thread not needed, etc. So it can fluctuate, I would say.
Okay, thank you very much for the answer. Next question, I really appreciate these questions, guys, so thank you very much for posting them, because it's one I also have. So the question is the following. I will just read it. Thanks for the nice overview. I wonder how to efficiently apply this knowledge in real work. Our apps evolve, and I assume that they might require re-evaluation of JVM settings periodically, which requires time, apparently. Are there any standard practices for integration of JVM memory tuning into active project lifecycle, and how not to spend too much time on this? And I will add one small question from my side. As in your story, like 99% of people will use standard setting. So how should I understand that my problem is not in the code, but in JVM, and I should start going and start tuning that?
First of all, you need to have a problem. Yeah, so you started. That's true. So you started, you deploy a project, you do like all the stuff, and everything is running fine. And my recommendation and the best practice is not to try to fix something that is already working, right? Now someone can come to you and say that, look, we need to reduce cost on infrastructure, we need to reduce the memory, etc. This is the point where you need to start thinking of your working applications, how to tune them. Yeah, so this is the first point. If no one is coming to you, I wouldn't do that, to be honest. So everything is running, everything is deployed wherever it's taken. The second point where someone can come to you, and this is especially true for low latency, yeah, for financial services, those high-frequency trading systems, etc. They have very, very hard non-functional requirements from the very beginning. So they know that your system needs to be tuned for something, for throughput, for example, or for I don't know, for memory. It's seldom, yes. So the memory in low latency is not that important. For them, the speed is important. Yes, so that's why the native memory and, let's say, the overall how much JVM takes, they don't care about it. So usually, if you have some non-functional requirements, then you need to start thinking about how to tune everything you do. Also, it is very important when you work with Docker containers. Yeah, if you want small images, if you want small, if you want them to take small amount of place on the real cloud server, yeah, then you can think about it. So best practices I don't think that they are really, at least that I am aware of. Yeah, they don't exist in what exactly flags you should tune first. First of all, of course, you need to think about how much heap do you need. Yeah, so you need to test your application real scenario and see, for example, you gave it 32 gigabytes and it takes 4. There is a sense to reduce it. Yeah, and at the same time, if you are constantly getting out of memory exception, yeah, because your heap went out, yeah, then you most probably need to increase it. The rest of the flags, I guess we will need to touch them when we really feel exact request or exact need. Also, can be a very good option to start looking at it. When the client is coming, for example, this is very, very common situation, I would say, that sometimes we are getting too slow response. For example, web service, yeah, sometimes it takes less than a second, and sometimes we are getting 5-8 seconds response. Then you could think that maybe this request came at the moment of your full GC with stop the world, and that's why your application was not responding for 5 seconds. And for them, it's important then you start thinking about, okay, what we can do with that. Either we tune garbage collector or we tune like in general memory, etc. So, but for those problems, there is no standardized approach. I don't know about them. Maybe there is, but I'm not aware of it. It's like every problem is different, and you need to approach it differently.
Yeah, I would add here that maybe the best approach here is experience and experimenting, like, and yeah, that would be the best for all of us. Okay, next question is the following one: is there any correlation between JVM's native memory tuning and the performance of the application? Maybe you are familiar with that kind of research, if there are any.
I don't know the research, but definitely what we were doing, every our action which we were doing had some implication to the yeah, you can share the screen because it's important to show. For example, when we tune garbage collector, it's already having the implication. Yeah, so different garbage collector will be acting totally differently. Yeah, so this is one thing. Compiler thing definitely we affected. If the application will be long living, disabling tiered compilation, it's like we will have significant drop in performance, I would say. Also, this stupid things, which not stupid but insane things, which we have done, yeah, like reducing shared class space, everything. Like, I will try to jump to something that we didn't discuss here, but it's important, yeah, that our JVM, it is not the single point of performance our application has. Because, for example, when you ask, like, where do you take the memory? Yeah, this is operating system which gives you the memory. So starting with like big heap, yeah, you will ask for a big heap. Definitely, it will take some time for OS, like bigger time to allocate you bigger memory. Maybe in single allocation it doesn't matter really, but if you will start like growing your application, yeah, it will be claiming, it will be each time call the memory manager of your operating system, and it will start to returning to like giving you the memory which you ask. Yeah, so if you, for example, at the beginning you will ask for a big chunk of memory, it will give it to you, and it will be much easier for your application. It will not ask every time to increase it and increase, because this is also like taking processor cycles, and it takes time to allocate some memory for you. Yeah, so it's not only even your tuning application flex has implication on the performance, but also operating system will be behaving a little bit differently depending on how your application is tuned. I'm not aware of any, because, you know, this is like every single topic we have discussed today, like compilation, like garbage collector, it deserves its own talk. And even those talks, they are like very much narrowed to some particular topic. Yeah. So when we are speaking about performance, like there are books written, yeah, on how this or the how to tune that, and what are implications of this or that action. So like Java Performance Tuning Guide, I guess, is the most famous. If you are interested in the resources, I can also share with you one very if you give me a second, I will share the nice. Here we go. I will show you my private mailbox. Java Performance and Tuning newsletter. This is a big research. I will open the initial page. Yes, so every month he is sending like one newsletter with some tools, with articles related to Java Performance, with the news. But what was like what was so amazing for me, let me go to the main page here. The guy is very, very consistent. If we go to like, it's like a newsletter from April 2021, and there are previous newsletter. And if we go here, you will see that he is publishing that starting from 2000. Yeah, this
Wow.
is the guy's name is Jack Shirazi, one of the like performance tuning like famous guys. This is his site. I encourage you, just for your interest. Never received a single letter of spam from him. So only once a month I receive the newsletter, and it's a reminder for me that yeah, I need to like to watch some news about that. So if you want to be like on the like answering about I don't know particular research how native memory footprint can be dependent on the can influence the performance. It's very complex topic. Yeah, every single change of JVM flag will influence that. But answering the question, if you would like to be on the same page and look at more advanced research than I do, for example, and watch those things, please, this is the best place where you can start your journey in the topic, I would say.
Yep. Thanks a lot for sharing. Thanks a lot for sharing the source. It's really, I would say, interesting to take a look at. Yeah, I see some comments in the chats. I would not like pronounce all of them as they are mostly like answering for the questions, and also like comments like for example like maybe you need to do all this performance stuff only when your code is ideal, only like when you try to improve performance in the code itself. So I would not read all of them. So I have the following question, which I really like. So we also play with heap size when we speak about Hello World, right? In the beginning, we have these like 800 maybe bytes. It's like some word I cannot get used to, but still. So question is the following. Are there any option or any way how to identify the heap size which we really need for any application? Well, I can rephrase it. So we have an application, right? So we have an application which we're developing, and we need to define the heap size for it so it won't be like more than needed and not be like the less. Also, we have a comment from Anton in the chat, which I really also like, that let give Java all the memory it wants. But still, are there any ways to calculate the heap size needed for the application?
Calculate theoretically before you start using it, very difficult, I would say. What I would do, I would run it and simulate the load. So let's say I will go to product and say, what do we expect? What load do we expect? Yeah, how this is going to be used, and we'll try to simulate it with
Gatling.
With JMeter, for example. Yeah, we can throw throw at your application some fake load, and you will receive some understanding. Yeah, so this is like average, this is the peak, this is something, this is how much you use. Yeah. Now give it whatever Anton told, give it all memory you want, give it the buffer you want to be safe. Yeah. For example, like if you are really not limited with memory, give it like 50%, yeah, more. If you are limited, give it like 20-30% more than the heap. I mean, not heap. The peak load, give it 20-30% more than the peak load, and you will be fine. And definitely at some point this can be like tuned. Yeah, so you notice that for example your dashboard is showing that at some point at peak your application was already at 95%. That is the good moment yet to revise. So 95 is dangerous. Yeah, so 90-95% is dangerous. Let's increase the heap.
I would say, I would add to this answer, which is a great one, that you maybe it's a good idea to enhance your CI pipeline with performance test run. So there are different tools, for example, like JMeter or Gatling, where you write your tests with Scala, and then it's run just in your CI pipeline, and it's just test your application maybe once a day, maybe on each commit, depends like how you want, and you will see these graphs, and you at some point you may define alerting, which will tell you that, hey, your application, when we do performance test, is already on some top. So maybe that's time to revise your settings. So yeah, that's definitely what you may want to do. at least you won't be scared of some out of members which just happening out of nothing. Yeah, I think last question, which I have here, for the JVM memory leak problems in legacy code. As an immediate relief, what would be recommended more, to increase the JVM memory size or to tune the JVM memory and garbage collector?
So we have legacy and we have memory leak.
So like, what should we do? Just give more memory to Java, or try to increase JVM to make it more, I don't know how to say it, more fit?
I would say that as a temporary solution, let's imagine that you have production, yeah, and you see that you are going to some out of memory problem very soon. So there are actually a couple of options how you can approach. First of all, yeah, give it more heap, restart, and wait until it will grow to your next highest heap. But you win some time. You win some time for investigation and for detecting this memory leak and for finding the solution. The second solution which comes to my mind, and for example, in financials, it's very, very feasible. You can make some scheduled restarts. Yeah, so if you, again, the best option, find memory leak, eliminate. Yeah, so this is like perfect solution, but we are not living in the perfect world. Yeah, so increase memory, this is the first thing. The second thing which you can do quite easily, schedule some restarts. So you notice that your memory becomes full in I don't know, 12 hours. Yeah, so find the slots where the load on your system is the smallest, yeah, and restart it then. That's
yeah. If your system contains several pods or several instances, you may restart them like one by one. Yeah, I also, it's fun because I just want to tell this story in the conclusion, because yeah, I heard these stories when people have like multi-tenant application with a lot of pods and stuff, and they have these memory peaks, but they could not use fully garbage collecting because it will take quite a lot of time because application is under heavy load. So they decided just to restart application each day. And this will save a lot of time on garbage collecting, but in the same time, they will not suffer from pauses to clean all the garbage. So that's kind of fun.
Working in such project. This is from my practice. Yeah. So business day, 8 o'clock till like 17, I guess it was. So we started our application around like 7. We started to do like warm-ups. We were pre-filling like everything we could, like all metadata we needed. And then like the whole day they were like, there was no garbage collection. They were growing. At 17 o'clock, business day finishes. We upload everything we have because we had a lot of in-memory keeping. There was some intermediate processes which were, and this was like extremely like KDB plus, it is called the storage. Yeah, it's a in-memory database. So there was some sync up during the day. But in general, in the end of the day, all the caches, all the like huge maps which we had of data were uploaded to database, to normal one. It was taking some time. And after this, shut down. Yeah, and this was the procedure which we were doing every day. I mean, it was automated, of course. We were not sitting like manually starting, and everything was automated. But still, it's like every morning, like right. One more interesting thing I have to share. This is already not finance. It was in bookmaking domain. So they have noticed that they have very high load on the weekends, and especially when the time of Euro 2000 something came, where they expected a lot of betting to be done on the weekends. They called it warming up the pods. So they were starting at some moment of time. They started to give a fake load to production system. So the production system was loaded, and the auto scaling feature started to scale the number of pods. Yeah, so without this load, yeah, we will start with small number of pods. The load will come, and we could crash, and we could lose very much of performance. But we started the fake load before actually peaks, which we knew. The auto scaling was increasing the number of pods, and we were very good at the peak levels. So this is.
I would say like the disclaimer and what's the outcome of these nice stories. So guys, all of these are instruments. So please don't take this like as advice how you should do your code right away. But still, all of these are instruments, and you are all of us are engineers. So let's use it wisely. So solution can be out of the box. Not every time it's like straight away. So maybe sometimes shutdown of the application or like fake load can be a solution. So let's that's basically our job, which none of the artificial intelligence can pick up in this space, because it's about our imagination. Okay, that's all questions. I think we answered most of them. Thank you, Vanya. Thank you very much for your talk. Thank you for your answer. Very valuable, very good. Thank you very much for being today with us.
Thank you, Roma, for inviting, and hope I will come once again someday.
Yeah, we will wait for sure. Guys, thank you very much for being with us today. Thank you for your comments and for your questions. Recording of the talk, as always, will be on our YouTube channel and on our community page. You will receive the feedback form. Please fill it. Don't forget that we already opened call for papers for Java On Conference, which will be this November. So please submit your talks, and you also already may register for it, so not to miss it. Also, yeah, subscribe to our community, subscribe to our channel, not to miss our webinars. That's it for today. Thank you very much. Have a good rest of the day, and yeah, applauses to all of us. Yeah, thanks a lot. Thank you, and bye.
Bye.